Hey, what's up, guys? Let's see. This live stream, we are running through the Elixir Getting Started guide, and this stream is going through the anonymous functions section. So this will be a lot of fun. Anonymous functions are cool, and we're going to learn a lot. Good to see you guys here, and welcome back, Sasha. It's always good to see you. All right. Well, I think we should just jump right in. I'm going to go ahead and share my screen. And let's get a browser open. And we'll jump over, we'll do elixir-lang.org. And then we're going to go to the guides here. And here we go. And we are now on anonymous functions. All right, so anonymous functions allow us to store and pass executable code around as if it were an integer or a string. So defining anonymous functions in Elixir are delimited by the keywords fn and n, end. So if we go ahead and look at this example here, we are setting an anonymous function equal to a variable called add. And why don't I just go ahead and pull up my terminal, make that a little bigger, and let's start a IEX Elixir shell session. All right. And as we run through this, I'm going to just go ahead and type this example. So we're setting an anonymous function equal to a variable name add. And an anonymous function starts with an fn, and then you define the anonymous function. So in this case, their example, it receives two arguments, A and B. Okay, and that's on the left side of the arrow operator. And then the returned results go on the right side of the arrow operator. And we're taking the two parameters passed in, so A, and we're adding it to B. And then to finish our anonymous function, we'll put an end there. All right. And then we can hit enter. And now we have this anonymous function stored in a variable that we can pass around and use. So to use this, we can do add dot, and then inside of parentheses, we can pass our two arguments. Just like that, and then close the parentheses. And when I hit enter, we get 3 back. So it added 1 and 2 together, which is pretty cool. And then we can also use the kernel function, is function, and pass in our variable. And this will return a Boolean and let us know if it's a function or not. And it's true, it's a function, okay? So that's a quick little example. So now we'll read through. So in this example above, we defined an anonymous function that receives two arguments, A and B, okay? And it returns the results of A plus B. The arguments are always on the left-hand side of the arrow operator, and the code to be executed is on the right-hand side. So the anonymous function is stored in the variable add. All right, and we just ran through that. It worked. It was really cool. And we can invoke anonymous functions by passing arguments to it. Now, if you noticed, we had to do the dot between the variable name and the parentheses. And this is required to invoke an anonymous function. So the dot makes it clear when you are calling an anonymous function, so stored in a variable. So in this case, add dot and then parentheses, just seeing that variable name, you now know that it's a function. So we now know it's an anonymous function. So opposed to a function named add arity to. So an anonymous function is stored in a variable instead of being like a named function. So in a named function, you'll always give the name and then do the / and how many arguments it accepts. But with an anonymous function, it's just a variable name. For example, if you have an anonymous function stored in a variable, is Adam, there is no ambiguity. Oh my gosh. See, every once in a while, I hit words that my mouth decides, you're not going to be able to say this today. ambiguity, and I'm not going to be able to say it. And then the second I end this live stream, I'll be able to say it. It's so fun to do embarrassing things on the internet. Between is Adam. So the Adam foo and is Adam foo, if both use the same is Adam syntax, the only way to know the actual behavior of is Adam would be by scanning all the code thus far for a possible definition of the is Adam variable. This scanning hurts maintainability as it requires developers to track additional context in their head when reading and writing code. All right, I feel like I need to reread that. For example, if you have an anonymous function stored in the variable is Adam. Okay. If both use the same is Adam syntax, the only way to know the actual behavior of is Adam. Yeah. Okay. Anonymous functions in Elixir are also identified by the number of arguments they receive. We can check if a function is of any given arity by using is_function arity2. So like we saw, we can pass in 2 arguments. So check if add is a function that expects exactly 2 arguments. All right, that's cool. So we know our add function accepts 2 arguments. So we can say is function, and then we can pass in add and the arity count, and we get true. And if we do the same thing and we know that it doesn't take 1 argument, we get false back. So that's handy. All right. All right, so now closures. Anonymous functions can also access variables that are in scope when the function is defined. This is typically referred to as closures, as they close over their scope. Let's define a new anonymous function that uses the add anonymous function we have previously defined. Okay, so we're creating another anonymous function, and then we're using the anonymous function that we just created to create a new anonymous function. So you can pass anonymous functions around like variables. And I think that's really cool. And it becomes very helpful. A lot of people will be like, when would you ever use anonymous functions? It doesn't make a lot of sense because they can be hard to maintain and understand and follow if they're too complicated. But the nice thing is for like enum map, reduce, what are some other ones? Like filter, all of those. So all of those like high order functions can accept an anonymous function because you pass in like enum map, you pass in a list as a variable, and then you actually write an anonymous function that you want it to execute. So you can, instead of having it all in one line, you can declare your anonymous function, set it to a variable, and then pass that variable into like your enum map function, which I think is handy, and it usually makes your code a little more readable. So that's kind of when anonymous functions can be handy. Obviously, there's a fine line between like readability and just writing named functions, because you can see how it works a lot easier. And you're probably only going to be using anonymous functions for like short-lived functions within other functions in your code base. I don't know. I kind of just rambled, but let's go ahead and try this example out where we're passing in an anonymous function to create another anonymous function that we want to just double the value that gets passed in. So if we pull up our terminal, we can say double equals, so that's our variable. And then we have to declare our anonymous function with an fn. This is only going to take 1 argument this time. And then we have our arrow operator. And now, since we already have add set, we can just say add, and then we can just do the dot notation. And then inside of parentheses, we want to double the value we're passing in. So we're just going to pass in a twice. Okay. Oh, extra parentheses. And then we can end this. And now when we hit enter, we can call this function and say double, and we can say, I want to double 2. and we get 4 back. So a variable assigned inside a function does not affect its surrounding environment. So this is kind of like the scope of like constructs that we talked about yesterday in the if case and conditional section. So if we declare a variable outside of the construct of our anonymous function, so if we do x equals 42, okay, that variable is now bound to 42. But then if we create an anonymous function, and we don't have to always set them, we can also do this. So fn in parentheses, and we can type our function, and we can set x just equal to 0. And then say end, and then close those parentheses. And then we can call it right here with just empty parentheses. And so we're binding x within this anonymous function to 0. So when we hit enter, we get 0 back like expected. But when we go to see what the value of x is, it's still 42 because x only got bound to 0 within the context of this anonymous function. And remembering scope of things is very important. Okay. Now let's move on. Clauses and guards. So similar to the case arity of 2, we can pattern match on the arguments of anonymous functions as well as define multiple clauses and guards. So this is really cool. As you can see, we're defining a function with multiple cases here. And if the pattern matches, so we're looking for 2 arguments, x and y, but this one will only be true if x is greater than 0. And if it's greater than 0, then we add them together. If it's not greater than 0, then we multiply them together. So it has 2 different cases inside of one anonymous function, which is pretty sweet. And you can see they add 1 and 3, we get 4. And then -1 is less than 0, so it's multiplied, so we get -3 back. So let's run through this. And all right, so we're going to have a variable named f, and we're going to set it to an anonymous function. And we can do multiple lines here because we have to have end to close off our anonymous function. So it takes 2 arguments, x and y, and then we can do a guard. So guard is when you use the when keyword, and we're checking to make sure x is greater than 0. If it's greater than 0, we have our arrow operator, and we're going to say we want to add x and y as long as x is greater than 0. And then if x isn't greater than 0, we're going to fall through and hopefully pattern match to this case, which we will as long as we have 2 arguments. Then we're going to multiply them together. So x times y. All right, and then we can end the my tongue tied. And then we can end the anonymous function here. And now we have f that will take 2 arguments. So we can say f dot, and then we can pass in our 1 and 3. And since 1 is above 0, these should add together to 4. Okay, cool. So that works as expected. And now if we change 1 to -1, it is now below 0, and we should get it multiplied together. So -1 minus or times 3 is -3. So that's cool. And now one thing we should note here is the number of arguments in each anonymous function clause, they need to be the same, otherwise you'll get an error. So we can't write this same function. So if we do f2 equals fn, and we say xy when x is greater than 0, we want to add them together, plus y. And then we can't have another pattern down here that says now we want x, y, and z, and we're going to multiply them all together. So when I hit enter here, we're going to get a compile error, and it's going to say you can't mix clauses with different arities in anonymous functions because the function only wants it, like it needs to take 2 arguments or 3 arguments, not 2 or 3, right? So there we go. We get yelled at, and at least we have a nice error message, so we know what we did wrong. All right. Oh, we got some questions. I come from Python, never used lambdas, and still don't wrap in my head when brings value to use anonymous functions over standard functions. Also, Elixir, my first functional language, so I'm learning the paradigm. Yeah, I mean, like I said, with like first order functions, like the map, like enum map and stuff, where you just want readability and you're just kind of declaring a function that you're going to pass into something. That's the only case that I've ever used them in. And you're not going to use anonymous functions often in the real world. At least I don't very often. It's more like, and a lot of times you just write an anonymous function in line in like an enum map, you know? So it really just breaks down to preference and if it works or not, because you don't want to make your code base hard to follow and like difficult to read, because obviously named functions are usually a lot easier to understand what's going on, because one, they're named. And as long as you name things well, you should know what that function does. And you don't necessarily have that with an anonymous function. Obviously, you can name the variable, but it's still not as clear what you're doing with the arguments you're taking in. My personal opinion, I could be wrong, and I'm open to anyone to give me a really, really solid example of anonymous functions. I think they're good to know, and yeah, I do use them to pass them into like first order functions though, or higher order functions. I don't know why I keep saying first order, but that's all I can tell you really. All right, now we have the capture operator. So throughout this guide, we have been using the notation, name / arity to refer to functions. It happens that this notation can actually be used to capture an existing function into a data type we can pass around, similar to how anonymous functions behave. So the capture operator is the ampersand right here. All right. And is_Adam is a function of arity 1. We can actually pass this function like that we can set it equal to a variable, and then we can run this like it's an anonymous function, which is pretty cool. So let's go ahead and try this out. So I'm going to just clear this so we're at the top. So if I say fun equals, and then we have our capture operator, and we're going to use the function. Now, when you use functions like this with the capture operator, you're going to notice you call the function and you pass in the arity as well. All right, and now we have this set to a variable fun, and we can say fun dot, and then we can pass in an atom, and we get true back because it is an atom. And if we try to do not an atom, we get false back. Where am I? Okay, so as you can see, once a function is captured, we can pass it as an argument or invoke it using the anonymous function notation. So that's the dot notation with the parentheses. The return value also hints we can capture functions defined in modules. All right, so isAtom is a kernel function, but we can also go into the string module and call functions there as well. So let's go ahead and pull up our terminal and do that. So we can also, we'll rebind fun, and we will say capture operator, string module dot length, and that's arity 1. And then if we say fun dot, and then we pass in a string here of hello, we will get 5 back. So it gives us the length of our string. And so we just set a module function to a variable, and then we can execute this function using the anonymous function notation. I think it can be pretty cool. And then so you can also capture operators. So we can do something like this. We could, like when we created our add anonymous function, we can just do this. We can say add equals, and we can use the capture operator. And we have the plus arity too, right? So that's the function for adding. We can do that. And now we have our add anonymous function, just like we had before, where it will take 2 arguments and we still get 3 back when we pass in 1 and 2. So the capture syntax can also be used as a shortcut for creating functions. This is handy when you want to create functions that are mostly wrapping existing functions or operators. Okay, so this is really cool. So what we have here is we have our variable that we're setting, and we're doing the capture operator, and then you'll see the &1 here plus 1. And the &1 is the first argument passed into the anonymous function. So if the multiple arguments were passed in, you would access them, &1, &2, so on. But like in this case, we're passing in 1 and we're grabbing the first argument and adding 1 to it. So that's all that's doing there. So let's see this in action. So if we say fun equals, and then we have our capture operator, and then we have the &1, which is the first parameter being passed into our anonymous function, and we're just adding 1 to it. And I should say that this is an anonymous function, but we are, I guess it is an anonymous function, but we're using the capture operator instead. So we're kind of wrapping around the addition function right now. So now we have access. So now when we call fun dot, so if we do fun dot and we pass in any argument we want. So if we pass in a 2, the &1 here is argument 1. We only have 1 argument. So it's taking 2 and adding 1 to it. So we get 3 back. So that's cool. And we can also do this with concatenation and strings and stuff. So if we do the capture operator, and then we can just do a string. So we can say good space, and then we can interpolate our variable, and we can say we want, parameter 1 here. So &1, and there's that. And so now we can say fun2, we can say, we can just pass in the string morning, and we'll get good morning back. So that's kind of cool. So the &1 represents the first argument passed into the function. So we have our capture operator, &1 plus 1. Above is exactly the same as fn. Okay. Yeah. So the capture operator is the same thing as doing fn and end as an anonymous function. So you can read more about the capture operator and its documentation. And we should probably do that at some point. So now let's revisit some of the data types we learned in the past and dig deeper into how they work. So in the next stream, we got some questions. All right. Let's learn together. What's up, man? What is /1? So when we talk about named functions, you always will have the name of the function, and then /1 is how many arguments or parameters that function takes. So for instance, the addition, so when you're just using the plus operator, it's +/2 because it takes 2 arguments. It takes, the first variable, the first value you're adding, and the second one. The string dot length is arity 1 because you're passing in 1 variable and you're getting the count back. So it's just how many arguments get passed into that function. It's just a nice shorthand version so you know. And Sasha already got you, so thank you. Thank you, Tamer. I appreciate that. So that was fun. I didn't screw up as badly as I did with was it the case statement that got me yesterday? This went a little smoother, but this was a lot of fun. So anonymous functions are pretty cool. And like I said, I use them for higher high level functions like enum stuff and map and reduce and that. But other than that, you're not going to don't get crazy with anonymous functions in your code base because you don't want to overcomplicate things for another dev that comes in and reads your code. But that was fun, guys. And I appreciate everyone that just joined in. And we will be doing binaries, strings, and char lists next week. I can't remember. I think I usually do things on Tuesday. Was our last stream on Tuesday? I did 3 this week, but I kind of made up for last week because I was out of town. And unfortunately, my live stream this morning got rescheduled, but it worked out. This is still fun. We learned about anonymous functions. We read some documentation together. But all right, guys, I appreciate it. And I hope everyone has a good weekend here. And I will see you in the next stream. I don't know why I couldn't talk right there, but have a good one, guys. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.